Good morning, everyone. Welcome to the homework portal. This is week 6. We have been solving problems, one problem per day, and we have been doing this since 5 weeks. It was a successful thing. And now let us come to 6th week, and now we are starting with the problem here. So, this will be for targeted for the IB1 students. Okay, so because it's totally focused on mechanics, and which means it involves only portions relative to A1, A2, and A3. For those who need this particular paper, so you can write back to me my email ID, or maybe you can comment on my YouTube if you want to, if you need the hard copy of it. So we can have a group, and maybe I can send it to you in that group. Okay, let us begin with this. Okay, the problem is for 16 marks, so I am having it for 16 minutes. Right. The diagram below shows part of a downhill ski course which starts at point A 50 meter above the level ground. Okay, from here, so this is a skier who starts from here. Okay, a skier of mass 65 kg. The mass of this skier is 65 kg. Starts from rest at point A. Starts from rest, U equal to 0 at point A. And during the sky course, some of the gravitational potential energy is transferred to the kinetic energy. So why does he say some of the potential energy might be there is some friction here, or maybe by some way you're losing some energy out of here, right? Okay. Now it says from A to B, 24% of the GP is transferred to kinetic energy. 24% of the potential energy is only transferred to the kinetic energy when the person skier reaches this point B. Okay, so what is the show the velocity at B is 12 meter per second. Now let us first find out what is the potential energy the person loses, okay, to kinetic energy, and then take 24% of it. Okay, so towards it. Now first find out what is the potential energy here. Potential energy at this point is mg into 50. The m is the mass of the skier. Potential energy at this point is mg into 20. So how much potential energy he has lost starting from here to here? It is subtract this from this one here. So therefore this should be mg into 30. This is the amount of potential energy the skier has lost when he starts coming from point A to point B. Okay. So therefore now mg into 30 is the potential energy which is lost, which has got converted, which should be get converted into kinetic energy. But it says, problem says that it's only 24% of the potential energy is lost, is being converted to kinetic energy, which means I'm going to multiply this by 0.24. This much amount, 0.24 times the potential energy lost by the skier is now converted into kinetic energy. What is kinetic energy? Half mv squared. Okay, this gives me the velocity or speed of the skier at point B. So I'll cancel this m and m over here. So I get Vb square is equal to 2 into 0.24 into g into 30, right? Vb square equal to so much. Let us calculate what is this value. So take the calculator. Now we have 2 into 0.24 into 10 into 30. I get the answer is 144. Square root of this one will be equal to 12. This is 144. Vb should be equal to root 144, which should be equal to 12 meter per second as required over here. Okay, now let us move on to the next one. Some of the GP is transferred into the internal energy of the sky is slightly increasing the temperature. When you are skying through the ice, definitely some amount of it will be transferred to the heat. Distinguish between internal energy and temperature. So what is the internal energy? Now, internal energy, what is internal energy? You are already studied in the earlier classes. In fact, this is a problem related to mechanics plus a little bit of the thermal physics. Internal energy is the sum of kinetic energy plus potential energy. Sum of kinetic energy and potential energy of what? Of not the person, of the molecules. You take up all the molecules, find out what is the kinetic energy, potential energy, sum of all those will give you this one. Now this is your internal energy. Now what is temperature? What is temperature? Temperature is nothing but the average of kinetic energy of the molecules. Okay, when you learn thermal physics, you'll get to know more about this one. So temperature is defined as the average of all the kinetic energy. Sum of average means total amount of kinetic energy. Sum of the kinetic energy is divided by total number of molecules, right? So average kinetic energy of all the molecules. Okay, let us move on to the next one. The dot on the following diagram represents the skyer as she passes to the point B. As she passes, where is the point B here? Point B is here. Point B, okay? The skyer comes here and it is at this point over here. This is your point B, it is at this point over here. She's still going like this over here, right? So therefore, okay, draw and label the vertical forces acting on the skyer. So this is the skyer over here. What are the forces acting here? First one is standing on the mound over here. It's actually moving over here. The first one is normal, is like this over here. Then there's a weight acting over here. Weight acting over here. Now you see, it has been shown by a curved path. Whenever there's a curved path, what do you get over here? You can see there's a centripetal force also acts over here. Okay, such that, see, centripetal force is not a real force. It's a force which is not a real force, which is a pseudo force. So such that, so what you need to do is, when you say draw and label the forces, you are not going to write centripetal force over here. You are going to write this value of W to be a larger arrow, which means that, so this force is much larger than this force. If they are not equal, and as a result of it, it's always been pulled like this. So you can expect the skyer to move around the curve over here. Okay. Now let us move on to the next one. Then the hill at point B has a circular shape with a radius of 20 meter. Radius is given over here. Then the moment you say circular shape, mv square by r will come. Determine whether the skyer will lose the contact with the ground at point B. Okay. Whether this is your point B here. Okay. If the speed is so high, there's a possibility that this will lose the contact and will fly off like this over here, right? Or is it that the person will always start moving like this? Now, what is the condition for it? That's what is the question over here. Now, towards it, what we will do is, let us find out what is the centripetal force acting on it. Centripetal force acting here should be equal to mv square by r. Now, what is m here? 65 kg, which we have already seen, right? See, it's given over somewhere over here. 65 kg skyer mass multiplied by velocity. What is the speed of the particle, speed of the person here? Which should be 12 square, 12 meter per second. We found it in the previous problem. Multiplied by, divided by r, which is 20 meter. When I do this, what is the answer I get? Let me take my calculator once again, which should be 65 star 144 divided by 20, which should be 468. 468 Newton. I get this over here. Okay, so this is mv square by r. So which means that, but what do I need here? I get a centripetal force. I need the centripetal acceleration. If I want centripetal acceleration, what should I do? A should be equal to centripetal force divided by mass, which should be 468 divided by 65. When I do this, what do I get here? 468 divided by 65. When you do this, I get 7.2. 7.2 meter per second square. Now, what you need to understand here is that, see, if this is 7.2 meter per second square, when it comes here, now what will happen? So this will also be pulled like this. It will also be pulled like this. If this acceleration is higher than 9.8, then automatically you will start flying over here. Okay. If it is lower than 9.8, the person will not fly, but will be sticking to the ground over here. Okay. So as a result of this, you can now say, since A is less than 9.8. What is 9.8? Acceleration due to gravity. Person or skyer, use the same terms, will always be in contact with the mount at the curved part of the surface. So he will not lose contact. Okay. Then, so how many marks? 3 marks. First mark will go for this one, second mark will go for this one, and third mark will be for interpretation. So you need to interpret it appropriately, only then you will get the full mark here. Then the skyer reaches point C with a speed of 8.2 meters per second. Where is point C here? Point C, where is point C? We need to go back. Point C is at this point. Okay, it's already reached the ground. Okay, at 8.2 meter per second. Okay, let me draw the diagram if you want. So it is like this, like this, like this, and then it comes like this over here. This is your point C. At what is the speed here? 8.2 meter per second. 8.2 meter per second. And then she stops after a distance of 24 meters at point D. Now, horizontally at point D, at a distance of 24 meters, its velocity becomes 0. Velocity becomes 0. Okay. Determine the coefficient of dynamic friction and okay. Determine the coefficient of dynamic friction. Dynamic friction mu between the base of the skies, between point C and the point D, assuming that the frictional force is constant and air resistance can be neglected. So very simple. So what do we do here? use V square equal to U square plus 2AS. Because he says frictional force is constant, right? You can use equations of motion. So what is V square? 0. What is U square? Initial velocity at point C, which would be 8.2 square plus 2A. I do not know what's the value of A. It's not 9.8. Don't take 9.8 over here, okay? Unless it's a free fall, okay? A pen falls downwards. Then you can take A equal to 9.8. Otherwise, do not take. Okay, yes. What is the value of S? 24 meter. 24 meter. So there's a retardation. Let us find out what is this value. So 2A into 24, which is a 48A, is equal to 8.2 square negative over here. Now let me use my calculator once again. So this should be 8.2 star 8.2 square divided by 48. When I do this, I get this is 1.4, 1.4 meter per second square. What is this value of A we have got? Retardation. But what is being asked? He is asking you to find out the value of mu here. Now, when the particle is going like this and is slowing down, why does it slow down? Because friction. Okay. So therefore, now you can see the frictional force acting backwards is nothing but frictional force is FF here, right? So if frictional force is equal to MA and there is a sliding friction, now I can write frictional force equal to mu times mg is equal to m into A. Cancels, so which implies A is equal to mu times G. And what is the direction? Direction is in the opposite direction. So I will get minus mu G here, right? Minus mu G here. So I will equate these two. So when I equate this, I get minus mu G is equal to minus 1.4. Then mu should be equal to negative cancels 1.4 by 10, which is equal to 0.14. The value of mu is equal to 0.14. Okay, let us move on to the next question. At the side of the course, flexible safety nets are used. Another scale of mass 76 kg. What was earlier mass? 65. Now you are using a different mass. Let us say M2. Now falls normally into the safety net with a speed of 9.6 meters per second. 9.6 meters per second. Okay. Calculate the impulse required from the net to stop the skier and state an appropriate unit for your answer. So what do you do here? The mass is given over here 76 and he falls it with this one. Now what is being asked? What is being asked is impulse. What is impulse? Impulse is F delta t, which should also be equal to M delta V, right? So because delta V by delta t is A, M into delta V is force. Delta V by delta t is force. Okay. So therefore now we want to get this value here. What is mass here? Mass is 76 kg. And what is delta V? Change in velocity. So what does happen over here? Another square of mass falls into the net with a speed of so much when it comes to rest over there, right? So this should be 9.6 minus 0, right? When it comes to rest, it is 0. Then what happens is this is 9.6. I take the difference in the speeds. So now let us calculate what is this value. This value would be 76 star 9.6. Will give you 729.6. It is a unit. Newton second. Newton second. Okay, he has asked both of them, right? So we got this one. Then he explained with reference to the change in momentum why a flexible safety net is less likely to harm the skier than a rigid barrier. So what will happen? So we know that F is equal to delta P divided by delta T. See, the force of impact should be lesser on him. So if force of impact has to be lesser, then delta P should be lesser. That you cannot have in your hand because already a skier comes with a very high velocity. You cannot stop them, right? But if this is not lesser, at least denominator should increase. Delta T should increase, which means what? The moment you fall onto it, the net that you have over here should sag for a long, right? When you catch a ball in a cricket, what do? You catch it, you just don't catch like this, but instead you catch it and bring it back towards you, right? So therefore, so you prolong the time on which the force is acting on you. So therefore, when you want to increase the delta T, then what happens? The safety net extends the time of impact. This implies delta T will become higher. This implies F will become lower, or the impact becomes lower. Okay. So with this we come to an end to the first question. Let us see the next question in the tomorrow's class. Okay. So wow, we have finished this question within 14 minutes itself. Okay. Thank you. Please do subscribe to my channel for more updates.